This is problem 4.52 in AOPS, Introduction to Number Theory. Jane writes the integers from 1 to 2000 on a piece of paper. She erases all the multiples of 3, then all the multiples of 5, and so on, erasing all the multiples of each odd prime. How many numbers are left when she finishes? So this is sort of like a trick question, but if you read it carefully enough, it's actually a really easy problem. So the first thing we think about is, let's just try to write all these numbers out. Let's just, for example, write the first few numbers, because we're not exactly sure what to do, so etc. So we'll write this up to 12, and then it says she erases all the multiples of 3. So it says all the multiples of 3, not just 1, not just 2, all the multiples of 3. So this all is important, because this also includes 3 itself. 3 is also a multiple of 3, right? 3 is just 3 times 1. So yeah, and then she erases all the multiples of 5. All means that this includes 5. So we have 5, 10, 15, etc. and so on, erasing all the multiples of each odd prime. So we start erasing 7 and the multiples of 7, like 7, 14, 21, 11, 22, 33, etc. until she finishes up till 2000. So as you can see, the numbers we have left are 1, 2, 4, 8. The next one is going to be 16, 32, 64, etc. These are essentially just the powers of 2. Because, so why are all the powers of 2's not crossed out or erased? Because we are erasing all the multiples of odd primes, and 2 is the only even prime. All the other primes have to be odd, right? Or else they would have a factor of 2, which doesn't make them prime. So 2 is the only even prime here, and it says erasing all the odd primes, all the multiples of each odd prime, including the prime itself. So the numbers we have left are powers of 2, numbers which only have a factor of 2. Numbers such as a, which have 2 to the power of n. Because if they had any other factor here, let's say we had 2 times 3, then this 3 would cause it to be erased when we are looking for multiples of 3 to cross out. So we are not crossing out any multiples of 2 though, however. So this means that only multiples of 2, or you can say powers of 2, is safe from the erasing process. So we have all the exponential forms of 2. So we have all the powers of 2 up to 2000. So we're trying to find out how many of these there are. So the largest power of 2 up to 2000 is going to be 1024, because the next one is 2048, which is larger than 2000. So how many powers are here? So this is essentially just 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, all the way up to 2 to the power of 10. 2 to the power of 10 is 1024. So there are 10 minus 0 plus 1, 11 numbers. So this sign is just for numbers. So we have 11 numbers, and that's our answer. So thanks for watching. The key in this problem is to remember that we have all the multiples of 5 and 3, all the multiples of every odd prime, including the prime itself. So we're not trying to count the number of prime numbers here plus the number of powers of 2. We're only trying to count the powers of 2, because those are the only numbers that haven't been erased by not being a multiple of any odd prime. So thanks for watching.